Hello everyone, and welcome to our next video. Just to give you a brief overview, we are working on a social media application based on a microservices architecture. And our main goal here is to learn how microservices work, what is the concept behind microservices, how they communicate with each other, and what are the problems that arise from implementing a loosely coupled structure for the different functionalities of our application. At the moment, we are developing the authentication service. We have only one service now, and we are working with the sign-up route. In the previous video, we implemented the functionality to hash the password of the user, right? So every time we save a user to the database and the password is modified, we will hash it and we will store it in the database, right? This is in this Mongoose pre-save hook. If the password is modified, then I hash it, and then I set the password to the hashed password. In this video, we are going to tackle this little additional test here, which is to check if both passwords are the same, meaning that I want to check if I take my original password and I hash it, or if I compare the hashed password and the original password using the salt that is stored in the hashed password. I want to check that they are the same, right? So what I would do is I would expect password hash from utils dot compare sync, and then here I would pass the hashed password, right? Something like this, the hashed password and the provided password, and I would expect them to equal the user info dot password, right? So, or actually, if I'm comparing, it doesn't make sense to, so I would just expect it to be truthy, right? And to be truthy, it means not only to return a boolean, but to return any value that is considered truthy. Or I can say even to equal true. And maybe this would be even more explicit what it is doing. So I would expect the compare sync between the hashed password and the provided password to equal true in this case, right? So maybe I even move this to another test because I think this would make sense. It should return true when comparing the hashed password with its original provided password, right? And this is very straightforward. It just tells me if you provide me the same password, I'm gonna use the salt that is for that specific user. If you provide me the same password, the compare method is going to return true. So I think that's fairly straightforward to understand, and it's not that hard to implement either. So I will just move this to the same, to a new test, and I will copy and paste this here. So now I'm creating a new user with user info, and this will automatically hash the password for me. So give it a couple of seconds. This is going to fail because we have no compare sync. We have the hashed password doesn't exist, provided password doesn't exist. So we will just implement them now. In the password hash class, I will create another static method, which is going to be compare sync. And this will again receive some arguments. And these arguments is they are going to follow the same pattern that we discussed in the previous video. So this is going to be password hash compare sync args. And what I need here, I need to have a provided password or a hashed password. Let's say a provided password, which is going to be a string A, and a stored password, which is also going to be a string, right? So now I can type this password hash compare sync args to the compare sync function, and it's going to return a boolean, right? It's going to tell me whether the comparison is true or false. So here I can extract these two attributes from my args object the provided password and the stored password. Now the stored password, if you remember it from tests here, it is going to have a dot in it, right? So if I split in this dot, the idea is that I have, so just to give you some overview here, maybe I write it here. Now the stored password is going to look something like this. Let me try to be more precise than the previous time and not add any wrong characters. Dot, let's say something like this, right? So this first part is the result of the script algorithm, and the second part is the salt. Now the idea is that if I take the provided password, right, and I pass over the same function, I should get the same hash, right? So if I take this one and I apply script sync, then I should get the same thing as here, and then I just return whether they are the same or not, right? So here what I will do is I will split this up. I'll take the stored password and I will split in the dot, and this is going to return me two separate strings, which I will already destruct them with an array here. So it's going to return me an array with two elements. So the first element is going to be the hash, the second one is going to be the salt. Now what I'm going to do is I will create my buffer, and it's exactly the same thing as the previous function. Now I will pass the provided password over the script function, over to the script function, and the same parameters with the same salt, and the salt here is coming from the stored password with the same keylen, right? Maybe I could even put this as a, let's say, constant here, not keyleg, keylen, and this can then, that's a constant, and this can then be used here and here, right? So typo in word keylen, I will just add it to the dictionary so it doesn't complain. Now I know that this is a constant. Maybe to be a bit more descriptive, password hash keylen, because then we know what's happening, right? Now the idea is that I can simply return the buffer as we did before here, buffer.toString to a hexadecimal string is equal to the hash. And if it is equal to the hash, this is going to return true. If it's not equal, this is going to return false, right? So here now I have the compare sync, and let's do a couple of add one more test here. So first one, I want to equal false, and I'm going to give a provided password, and this is going to be, let's say, 1234, and the stored password is going to be the new user dot password, right? So this should be false because the provided password is not the same as the original stored password. This should be false. And now if I come here to the second function, what I will do is, if I pass the user info here, the user info dot password as the provided password, and the new user dot password as the stored password, then this should be true. I think that this should be all that we need to make this test pass, so that we can have a fully functional password hashing implemented in our code. Now you see, this is not a lot of problem, right? It's not a lot of code, because most of the work is done by this little function script sync. Now we could think about testing this function. Oh, does it really encrypt my password correctly? But it's not our scope, right? If we are using this function, we assume automatically that the people who implemented it, and I'm pretty sure that they implemented it correctly because it's a native function from Node. But if they implemented it, they followed the guidelines and the algorithm from, I think it's the NITS or NTIS, I don't remember now. But it's not within our scope to test this function, right? In fact, whenever we use functions from external modules, external packages, we will hardly ever focus on testing their specific behavior. We will assume that they will work as expected because it's the responsibility of those implementing the module or the library or the package to test it. And it's our responsibility as good developers to ensure that we don't go browsing the web and picking up whatever package we find that tells us that it does functionality X, right? If there was a very shady package that implemented a script, you could be sure that maybe, or maybe not be sure, but you could be highly suspicious that maybe the person or the people who implemented that package, they have some way of figuring out which passwords get stored, and it's not secure, so it's probably there so that they can break into some account. So we need to be careful when choosing these things. It's better to stick to the native implementation and assume that it's well tested and well implemented. Good. I think this is enough for this video. We are done with the password hashing, so I think I can come back to my board here and move this to done. Right, it's very nice. What we are going to do next, we are going to work with the verification email to the provided, with sending the verification email to the provided user email. I will give some introduction to this topic in the next video. It's a fairly complex topic, not because of the functionality, but because of the dependencies of our system. So when we think about sending an email verification, this means let's use a service, right? So that we don't need to implement the whole package ourselves. Let's use an API maybe, or another module like Node Mailer to send this email to us in our name. And the problem is that we are writing a test-driven application, which means that this would send a lot of emails because we run a lot of tests, right? So we need a way of addressing this problem and having a different behavior in our tests. And maybe you are thinking mocking, and I'm telling you, let's go a little bit beyond mocking. We are going to use some design patterns, mainly the dependency inversion principle, right? So that we can extract the dependencies to something else, to some another class, and we can set them wherever we want. So we can set a different class during testing, and we can set another class during production, right? I will come back to this topic at the beginning of the next video, and we will see with maybe some nice diagrams how this will look like. For the moment, I will consider the encryption of the password as done. Thank you for your time and see you in the next video. Bye bye.